chromium, due to the off-field stable electronic configuration, it is showing the exceptional electronic configuration compared to the manganese, ferrous, cobalt and nickel. Now zinc and copper should have the less ionization energy. This titanium dioxide is a amphoteric. Yakandre titanium dioxide oxidation state is to now find madubodu pyrolusite is the chief ingredients of the manganese dioxide. Hello my dear friends, elrigu namaskara. Myself Kodam Naveen Kumar, ನಿಮ್ಮ chemistry faculty. Okay, ನಾನು ಇವತ್ತು ನಿಮ್ಮ ಮುಂದೆ ಬಂದಿದ್ದೀನಿ with summer lecture, summer series or summer lecture ಅಂದ್ರೆ ಏನಂದ್ರೆ ಈಗ the chapter we are going to see the summary of the chapter. ಅದು ಯಾವ chapter? The D and F block elements. D and F block elements summary ಅಂದ್ರೆ ನಿಮ್ಮ PUC ಅಲ್ಲಿ KCET ಮತ್ತೆ JEE ಮತ್ತೆ NEET ಈ ಎಲ್ಲ ಎಂಟ್ರೆನ್ಸ್ ಗು summary ತರ ನಾವು D and F block ಒಂದು ಕ್ವೆಶ್ಚನ್ ಪಕ್ಕ it will get in your when KCET or JEE as well as a NEET one question definitely it will be there. Now what type of the summary we are going to see, what are the important points, now that we are going to see in our lecture. Now let's start ಮಾಡೋಣ. Now start ಮಾಡೋಕೆ ಮುಂಚೆ now introduction of the chapter, the D and F block of the introduction ಏನಂದ್ರೆ now the modern periodic table has been divided into 4 blocks ಅಲ್ಲ. Now here this is the S block. Now here there will be the D block and here it will be the P block ala. No, here F block. Okay, the modern periodic table has been divided into 4 blocks. Idi yavado? This is S block. No, idi yavado? P block. No, idi yavado? F block. No, idi yavado? D block. Okay, now S block, P block, D block, F block. Now first 2 groups consist of S block and last 6 groups consist of the P block. ಇದರಲ್ಲಿ 2 ಗ್ರೂಪ್ಸ್ ಇರುತ್ತೆ, ಇದರಲ್ಲಿ P block ಅಲ್ಲಿ 6 ಅಲ್ಲ. Okay, now 6 groups. Now D and F blocks are sandwiched between the S block and the P block. ಇಲ್ಲಿ ನೋಡಿ S block ಮತ್ತೆ P block ಅಲ್ಲಿ sandwiched ತರ ಇದೆಯಲ್ಲ, this is D block, ಇದರಲ್ಲಿ F block ಇರುತ್ತೆ. But instead of placing in the main part of the periodic table, they have placed in the ಕೆಳಗಡೆ they have placed. Okay, now here D and F block. Now the D block of the periodic table consists of the elements from the 3 to ಇದರಲ್ಲಿ 3 to 12 groups ಇರುತ್ತೆ D block ಅಲ್ಲಿ, and it will start from the 4th period. It will start from the 4th period. Now ಇಲ್ಲಿ ನೋಡಿ, here the D block elements, this is the first, this is second, this is third, and this is 4th, 5th, 6th and 7. Now D block elements will start from the 4th period. D block elements will start from the 4th period. Now progressively filled by the each of the 4 long periods. Okay, next. Now definition of the transition elements. Definition of the transition elements ಏನಂದ್ರೆ ಈಗ transition element D block elements ಎಲ್ಲಾನು transition elements ಅಂತಾರೆ except zinc, cadmium and the mercury. Zinc, cadmium and the mercury, why they are not calling as the transition elements ಹೆಂಗಂದ್ರೆ, ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ here transition elements ಇಲ್ಲಿ ನೋಡಿ, transition elements is defined as a one which has incompletely filled d orbitals in its ground state or any one its oxidation state. Or here incomplete d orbital ಇರಬೇಕು in its elemental state or ground state or any oxidation state ಈಗ ಜಿಂಕ್ ಗೆ ನೋಡಿ, ಜಿಂಕ್ ಅಟಾಮಿಕ್ ನಂಬರ್ ಎಷ್ಟು 30 ಅಲ್ಲ, means here this is 4s2 3d10, 4s2 3d10. Here 4s2 has been this completed, Now D also has been completed alla. This D also completed. 4 is completely filled. ಈಗ zinc, if you remove one electron, ಇಲ್ಲಿ ನೋಡಿ, now the last electron according to the above principle ಅಲ್ಲಿ last electron will enter into the D subshell alla, but 4s2 is the valency shell. Now electron remove ಮಾಡೋಕೆ valency shell ಇಂದಾನೆ remove ಮಾಡ್ತೀವಿ. Okay, from the 4s2 only the electron will be removed. Now if you remove one electron, now here the D orbital is completely filled, only it will be removed from the 4s. ಈಗ Zn2 plus, if you remove the 2 electrons, even though if you remove the 2 electrons, that electrons will be removed from the s orbital only. D ಅಲ್ಲಿ completely filled D orbitals ಇದೆ, ಅದಕ್ಕೋಸ್ಕರನೇ. But there is Zn plus 3, Z, ಯಾಕಂದ್ರೆ here zinc it will not show the +3 oxidation state. ಯಾಕಂದ್ರೆ ಈಗ ನೀವು this is D10, this is a stable electronic configuration ಅಲ್ಲ, stable electronic configuration. If you remove one electron it will become D9, ಅದಕ್ಕೋಸ್ಕರನೇ it will not show the Zn+3 oxidation state. That's the reason zinc is not a transition element. Zinc is not a transition element. But copper, ಈಗ ನೀವು ನೋಡಿ ಕಾಪರ್ ಗೆ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಎಷ್ಟು? 4s1 3d10 ಅಲ್ಲ, 4s1 3d10. ಬಟ್ ನಿಮಗೆ ಇದರಲ್ಲಿ ಈಗ ಡೌಟ್ ಆಗುತ್ತೆ, ಸರ್ ನೀವು ಕಾಪರ್ ಈಗ D10 ಫಿಲ್ ಇದೆ ಅಂದ್ರೆ ಅದು ಟ್ರಾನ್ಸಿಷನ್ ಮೆಟಲ್ ಅಲ್ಲ. ಬಟ್ ಇಲ್ಲಿ ಕಾಪರ್ ಇಸ್ ಅ ಟ್ರಾನ್ಸಿಷನ್ ಮೆಟಲ್. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ Cu+2 ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನು? 4s0 3d9 ಅಲ್ಲ, 3d9. No, 3d9. ಅದಕ್ಕೋಸ್ಕರ here there is one incompletely filled d orbital. Due to the presence of incompletely filled here, that's the reason I said you right, either in the elemental state or in its ground state or any of its oxidation state or any elemental state, it should have a empty or it should have a partially filled d orbital, partially filled or half filled or incompletely filled d orbital. Then we can say it as a transition element. If it is a completely filled, then we will not say it as a transition element. ಅದಕ್ಕೋಸ್ಕರನೇ zinc, cadmium and the mercury, these are not the transition metals. But zinc is a transition metal. Why? Because in its oxidation state it is having the incompletely filled d orbital. Okay, now this is the definition of the transition elements. Next, electronic configuration of the d block elements. Electronic configuration of the d block elements ಏನಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, now d block elements will start from the fourth period ಅಲ್ಲ, and it is having the 3 to 12 group, and it will be present in the 10 elements. It is present in the 3 to 12 group ಅಲ್ಲ. Now electronic configuration, general electronic configuration of the d block elements ಏನಂದ್ರೆ n-1d 1 to 10 and ns 0 to 2. ಅಂದ್ರೆ this is a penultimate. ಈಗ this is a nucleus ಅಲ್ಲ, this is nucleus. Now this is the first shell, this is the second shell, this is the third shell, this is the fourth shell. ಈಗ if it is a ultimate shell, this is a ultimate shell or valency shell. Now this will be the penultimate shell. ಇಲ್ಲಿ ನೋಡಿ, now ns is the valency shell or ultimate shell. Now n-1d is the penultimate shell. ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, if this is a 1s, ಇದರಲ್ಲಿ 2s 2p, 3s 3p 3d, ಇದರಲ್ಲಿ 4s. okay, now this is the general electronic configurations of the d block elements. This is the general electronic configuration. Now here d blocks elements will start from the fourth period ಅಲ್ಲ, fourth period ಅಲ್ಲಿ starting element ಯಾವುದು? scandium to zinc. Now here 3d series ಗೆ general electronic configuration ಏನಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, 4s2 4s2 3d 1 to 10. Sorry, 4s2 1 to 2. 4s 1 to 2 3d 1 to 10. ನಾನು why I have written a 1 to 2 ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ ಕ್ರೋಮಿಯಂ ಮತ್ತೆ ಕಾಪರ್, ಕ್ರೋಮಿಯಂ ಮತ್ತೆ ಕಾಪರ್ಗೆ ಎರಡು ದೇ ಆರ್ ಹ್ಯಾವಿಂಗ್ ದ ಎಕ್ಸೆಪ್ಷನಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್. ಯಾಕಂದ್ರೆ ನಾವು ಹಿಯರ್ ಕ್ರೋಮಿಯಂ ಡ್ಯೂ ಟು ದ ಆಫ್ ಫೀಲ್ಡ್ ಸ್ಟೇಬಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ it is showing the exceptional electronic configuration. Okay, due to the off field stable electronic configuration, d5 stable alla, d5 due to the presence of d5 stable electronic configuration, chromium is showing the exceptional electronic configuration. Illi nodi copper due to the presence of d10 stable electronic configuration, copper in ಕೊಡ್ತಾ ಇದೆ exceptional electronic configuration ಕೊಡ್ತಾ ಇದೆ. ಓಕೆ, ಮತ್ತೆ ಇಲ್ಲಿ ನೋಡಿ 4D ಸೀರೀಸ್ಗೆ 5s 0 to 2, 5s 0 to 2, 4D 1 to 10. This is the general electronic configuration for the 4D series. ಇಲ್ಲಿ ನೋಡಿ 4D ಸೀರೀಸ್ಗೆ ನಾನು 0 ಆಗಿದ್ದಾನಲ್ಲ, ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ palladium it's showing the exceptional electronic configuration. Palladium is showing the exceptional electronic configuration for the D10 completely filled electronic configuration. Here the D is completely filled alla? D is completely filled. For more stabilization, for more stability, palladium it is showing the exceptional electronic configuration. Adikoskarane it is having the 4s0 and the D10 completely filled electronic configuration. And here you can see here rubidium, molybdenum, technetium, ruthenium, rhodium, these all are having the exceptional electronic configuration. Now 5D series it will start from the 6s 1 to 2. Now 5D 1 to 10, 5D 1 to 10. Now 5D series it will start from the here itself lanthanum and it is ending to the mercury. ಇಲ್ಲಿ ನೋಡಿ ನಾವು ಇದರಲ್ಲಿ ಹಿಯರ್ ದ F block elements ಬರುತ್ತೆ, ಹಿಯರ್ ದ F block elements ಬರುತ್ತೆ. ಇಲ್ಲಿಂದನೂ ಸೇಮ್, ಹಿಯರ್ ದಿಸ್ ಇಸ್ ಅ lanthanides, here it is a actinides. Now here 6D series general electronic configuration ಏನು 7s 1 to 2, 6D 1 to 10, 6D 1 to 10. Now these are the elements that are present in the D block elements, and these are the some general electronic configurations. Okay, next general properties of the transition elements. General properties of the transition elements. First we are going to see the melting point of the transition elements. Melting point. Now ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಇಲ್ಲಿ ನೋಡಿ ಫಸ್ಟ್ 3D ಎಲಿಮೆಂಟ್ಸ್ ಬರ್ರಿ. 3D series ಎಲಿಮೆಂಟ್ಸ್ ಯಾವುದು? ಫಸ್ಟ್ ಈಸ್ ಸ್ಕ್ಯಾಂಡಿಯಂ, ನೆಕ್ಸ್ಟ್ ಈಸ್ ಟೈಟಾನಿಯಂ, ನೆಕ್ಸ್ಟ್ ಈಸ್ ವ್ಯಾನಡಿಯಂ, ನೆಕ್ಸ್ಟ್ ಈಸ್ ಕ್ರೋಮಿಯಂ, ನೆಕ್ಸ್ಟ್ ಈಸ್ ಮ್ಯಾಂಗನೀಸ್, ನೆಕ್ಸ್ಟ್ ಈಸ್ ಫೆರ್ರಸ್, ಕೋಬಾಲ್ಟ್, ನಿಕೆಲ್, ಕಾಪರ್ ಅಂಡ್ ದ ಜಿಂಕ್ ಅಲ್ಲ. ನಾವು ಇದರಲ್ಲಿ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಈಗ ಜಾಸ್ತಿ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆಯಾ ಅಂದ್ರೆ ಮೋರ್ ವಿಲ್ ಬಿ ದ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್. ಜಾಸ್ತಿ ಅನ್ಪೇರ್ಡ್ ಇಲ್ಲ ಅಂದ್ರೆ ಮೋರ್ ವಿಲ್ ಬಿ ದ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್. ಇಲ್ಲಿ ನೋಡಿ ನಾವು ಸ್ಕ್ಯಾಂಡಿಯಂ ಎಷ್ಟು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೆ? ಸ್ಕ್ಯಾಂಡಿಯಂ 1, ಯಾಕಂದ್ರೆ 3D 1 ಅಲ್ಲ. ನಾವು ಟೈಟಾನಿಯಂ 2, 3D 2 ಅಲ್ಲ. ವ್ಯಾನಡಿಯಂ 3, ಯಾಕಂದ್ರೆ 3D 3. ಕ್ರೋಮಿಯಂಗೆ ಎಷ್ಟು? 6, ಯಾಕಂದ್ರೆ ವೇರಿಯಬಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಇದೆಯಲ್ಲ. 4s1 3D 5, 4s1 3D 5. ಮ್ಯಾಂಗನೀಸ್ಗೆ ಎಷ್ಟು? 5. ಫೆರಸ್ ಎಷ್ಟು? 4. ಕೋಬಾಲ್ಟ್ ಎಷ್ಟು? ಕೋಬಾಲ್ಟ್ ವಿಲ್ ಬಿ 3, ನಿಕೆಲ್ ವಿಲ್ ಬಿ 2, ಕಾಪರ್ ವಿಲ್ ಬಿ 1, ಜಿಂಕ್ ವಿಲ್ ಬಿ 0. Okay, these are the melting points we are having. ಅದಕ್ಕೋಸ್ಕರನೇ more the melting, more the unpaired electrons, more the unpaired electrons, more will be the melting point, more will be the melting point. ಇಲ್ಲಿ ನೋಡಿ, up to scandium to chromium melting point is increasing. ಇಲ್ಲಿಂದ ನೋಡಿ, scandium, titanium, vanadium, chromium. After coming to the chromium, sudden dip for the manganese. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಮ್ಯಾಂಗನೀಸ್ಗೆ d5 stable electronic configuration ಇರುತ್ತೆ. d5 stable electronic configuration ಇರುತ್ತಲ್ಲ, due to the presence of d5 stable electronic configuration, now here manganese will not form the bond strongly. Manganese will not form the bond strongly. ಅದಕ್ಕೋಸ್ಕರನೇ its melting point will be low. Manganese will not form the stable bonds. ಅದಕ್ಕೋಸ್ಕರನೇ manganese it is having the what? Having low melting point. Alinda next, here you can see, here from the ferrous it will be increase unpaired electron. After that it is decreasing. And it will be decrease up to the zinc. Again up to zinc. Zinc it is having the 0 unpaired electron. Zinc it is having the low melting point. Okay. Next. Here more melting point it is having the tungsten. It is having the more melting point. Next, atomic size and the ionic size. Atomic size and the ionic size ನಾವು ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ, ಈಗ in our periodic table if you move from the left to right, ಏನಾಗುತ್ತೆ? left to right radius decreases ಅಲ್ಲ, ಅಂದ್ರೆ size is decreasing. When we move from the left to right, atomic size decreases ಅಲ್ಲ. But when it comes to the 3D series, 3D series ಯಾವುದು? scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper and the zinc ಅಲ್ಲ. ನಾವು ಇಲ್ಲಿಂದ ನೋಡಿ, now when we move from the left to right, atomic size should be decrease ಅಲ್ಲ, but ಇಲ್ಲಿಂದ ನೋಡಿ, scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel and the zinc is having the higher atomic size than the manganese, ferrous, cobalt, nickel and the copper. But as per our periodic table trend, now how it should be? Zinc should be the less size ಅಲ್ಲ, but ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ನಾವು ನಾನು ಆಟಮ್ ಬರ್ತಾ ಇದ್ದೀನಿ. now this is 3D, now this is 4s, now this is the valency shell ಅಲ್ಲ, this is 4s. now last electron will enter into the n-1d shell ಅಲ್ಲ, 1d shell means here this electron is attracting the nucleus. now whatever the electron is adding into the penultimate shell, now this electron should be repelled. This electron is repelling, but how much repelling is happening? That much repulsion is not happening. That's the reason here the radius is decreasing. Up to here, up to scandium to chromium, here this valency electron is attracting towards the nucleus. now this inner electron is repelling this valency electron. ಅಲ್ಲ. now ಇಲ್ಲಿಂದ what it is going on? What's going on? Attraction and repulsion ಅಲ್ಲ, attraction and repulsion. ಈಗ attraction ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ರೇಡಿಯಸ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಈಗ ರಿಪಲ್ಷನ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ರೇಡಿಯಸ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ರಿಪಲ್ಷನ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ರೇಡಿಯಸ್ ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಬಿಗ್ ಅಲ್ಲ. ನಾವು ಇಲ್ಲಿಂದ ನೋಡಿ, compared to the scandium to the chromium, repulsion versus attraction, attraction is more dominating. more dominating than repulsion. Okay, that's the reason scandium, titanium, vanadium and chromium. Now here the manganese, ferrous, cobalt, nickel, up to here all are having the nominal radius, same radius. Now yakandre illi nodi, here the attraction and the inner electrons is repelling this electron alla, means here how much attraction is happening, the same repulsion is happening. ಎಷ್ಟು ಅಟ್ರಾಕ್ಷನ್ ಆಗ್ತಾ ಇದೋ the same repulsion is happening. ಅದಕ್ಕೋಸ್ಕರನೇ this all having the radius same, all are having the radius same. But when it comes to the copper and the zinc, copper and the zinc it is having the stable 3d10 electronic configuration. Idralli it is also having the stable electronic configuration alla. Due to the presence of stable electronic configuration, attraction and repulsion is more dominating. Repulsion is more dominating alla. Adikoskarane this copper and the zinc is having the more size. Illinda nodi, first up to here radius has been decreased. Here the repulsion and the attractions are predominating. It is cancelling out each other. How much repulsion is happening, astin the attraction also is happening. So the radius is same. But when it comes to the copper and the zinc, due to the presence of stable electronic configuration, alinda repulsion ಜಾಸ್ತಿ ಇದೆ more than the attraction. Okay, now this is the atomic size. Now when this is from the left to right. Now when you move from the top to bottom, ಇಲ್ಲಿ ನೋಡಿ top to bottom ಗೆ ಏನಾಗುತ್ತಂದ್ರೆ, here scandium, now let's take titanium, nubidium. Now here or else, now when we move from the top to bottom, now titanium is having the smaller size than the zirconium. But when it comes to the hafnium, zirconium and the hafnium, it is having the similar size. I mean not small and not, it is having, both are having the similar size. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, now ಇಲ್ಲಿಂದ 4f series start ಆಗುತ್ತಲ್ಲ, now this is the 5s. now here this is a 4s, this is the 5s, and this is the, here this is 4s, this is 5s, and here it is a 6s. Due to the presence of these 4f electrons, these 4f electrons are poor shielding. These 4f electrons are not protecting the valency electron. Adigoskarané this hafnium radius will become less. That's the reason this we call it as a lanthanide contraction. Due to the lanthanide contraction, hafnium radius has been decreasing. Here the valency electrons is not protected by the 4f electrons. Adigoskarané hafnium size is decreasing. Okay, next. Now ionization enthalpy ಏನಂದ್ರೆ, now when we move from the left to right, ionization energy increases. ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel and copper and the zinc. Sir, ಈಗ ನೀವು ಹೇಳಿದ್ರಲ್ಲ, ಇಲ್ಲಿ ನೋಡಿ, here zinc as having the higher radius. Zinc is having the higher radius, so that compared to the manganese, ferrous, cobalt and nickel, now zinc and copper should have the less ionization energy. Okay, ನಿಮಗೆ ಆ ಡೌಟ್ ಬರುತ್ತಲ್ಲ, ಸರ್ as the radius increases ionization energy decreases. ಸರ್ ಇದು ನಾನು ಕಲಿತಿದ್ದೀವಿ, ಬಟ್ ನೀವೇನೋ ಹೇಳ್ತಾ ಇದ್ರಿ ಇಲ್ಲಿ zinc is having the higher ionization energy. Now zinc and the copper is having the higher ionization. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, when we move from the left to right, ionization energy is increasing, but radius for this both is higher. Radius for this size is higher, but ionization energy ಜಾಸ್ತಿ zinc. ಯಾಕಂದ್ರೆ zinc electronic configuration ಏನು 4s2 3d10 ಅಲ್ಲ. Now this is the stable electronic configuration. Now due to the presence of stable electronic configuration, stable electron configuration ಅಲ್ಲಿಂದ ನೀವು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಸ್ಟೇಬಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಅನ್ಸ್ಟೇಬಲ್ ಅಲ್ಲ. ಮೇಕಿಂಗ್ ದ ಅನ್ಸ್ಟೇಬಲ್ ರಿಕ್ವೈರ್ಸ್ ಹೈಯರ್ ಎನರ್ಜಿ. ಅದಕ್ಕೋಸ್ಕರನೇ ಜಿಂಕ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಹೈಯರ್ ಅಯನೈಸೇಷನ್ ಎನರ್ಜಿ. ನೌ ಕಂಪೇರ್ ಟು ದ ಜಿಂಕ್, ಕಾಪರ್ ಅಂಡ್ ದ ಜಿಂಕ್ ಇಲ್ಲಿಂದ ಎರಡಲ್ಲಿ ಯಾರ್ದಿಗೆ ಜಾಸ್ತಿ ಅಯನೈಸೇಷನ್ ಇದೆ ಅಂದ್ರೆ ಕೇಳಿದ್ರೆ ಜಿಂಕ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಹೈಯರ್ ಅಯನೈಸೇಷನ್ ಎನರ್ಜಿ. ಯಾಕಂದ್ರೆ ದಿಸ್ ಈಸ್ 4s2 3d10 stable electronic configuration. Due to the presence of stable electronic configuration, now it is having the more ionization energy. But ಈಗ ಅಲ್ಲಿಂದ ಈ ಎರಡಲ್ಲಿ ಫಸ್ಟ್ IE ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ ಫಸ್ಟ್ IE ಅಂದ್ರೆ ಈಗ ನೀವು ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಬಿಕಮ್ Cu+1 and it will become Z+. Now ಇದರಲ್ಲಿ which is having the higher ionization energy ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ Cu+ is having the higher ionization energy. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿಂದ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿಂದ 3d10, here it will become the 4s1 3d10. Now this is having the stable electronic configuration ಅಲ್ಲ. Due to the presence of the stable electronic configuration, now IE1 for the Cu+ will be more. In the ground state ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ zinc is having the more ionization energy than the copper. Okay. Oxidation states. Now transition elements will show the different and the variable oxidation state and the maximum oxidation state for the transition elements is maximum oxidation state for the transition state is +2. ಯಾಕಂದ್ರೆ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಅಲ್ಲಿ 4s2 this general electronic configuration ಏನು 4s1 to 2 3d 1 to 10 ಅಲ್ಲ. Now the valency electrons, these are the valency electron ಅಲ್ಲ. Now here but in the transition elements the bond is taking place. Now in a chemical bonding ಅಲ್ಲಿ ನಾವು ಕಲ್ತಿದೀವಲ್ಲ, ಏನು ಕಲ್ತಿದ್ವಿ, only valency electrons will take part in the bond formation. But transition elements ಅಲ್ಲಿ valency shell ಮತ್ತೆ inner transition d shell also will participate in the bonding. This both 4s and 3d both will form bonding. Now here scandium it is showing the stable electronic configuration of the +3. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ ಸ್ಕ್ಯಾಂಡಿಯಂ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನು 4s2 3d 1 ಅಲ್ಲ. ಈಗ ನಾನು ಫಸ್ಟ್ if I remove these two electrons ಎಷ್ಟು ಇರುತ್ತೆ 3d1 ಅಲ್ಲ. if I remove the 3 electrons, now scandium will reach to the krypton electronic configuration ಅಲ್ಲ. krypton electronic configuration the noble state electronic configuration ಅಲ್ಲ. noble gas or noble state electronic configuration ಅಲ್ಲ. ಅದಕ್ಕೋಸ್ಕರನೇ scandium will show the stable oxidation state +3. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ ಸ್ಕ್ಯಾಂಡಿಯಂ ಈಗ ನಾನು 3 ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ದ ನೋಬಲ್ ಸ್ಟೇಟ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್. ಅದಕ್ಕೋಸ್ಕರನೇ ಸ್ಕ್ಯಾಂಡಿಯಂ ವಿಲ್ ಶೋ ದ +3 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್, ಸ್ಟೇಬಲ್ +3 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ನಾವು ಸ್ಕ್ಯಾಂಡಿಯಂ ನೋಡಿದ್ರೆ ಇಟ್ ಈಸ್ ಶೋಯಿಂಗ್ ದ ಸ್ಟೇಬಲ್ +4 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ಯಾಕಂದ್ರೆ ಈಗ 4 ಎಲೆಕ್ಟ್ರಾನ್ ನಾನು ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ರೀಚ್ ಟು ದ krypton electronic configuration. Okay, sorry, argon. Now vanadium electronic argon electronic configuration. Now vanadium ಅಲ್ಲಿ ಈಗ ನಾನು 5 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಎಲ್ಲಿಗೆ ಬರುತ್ತೆ? ಆರ್ಗಾನ್ಗಳ. ನೋ. ಕ್ರೋಮಿಯಂ ಸಿ ಕ್ರೋಮಿಯಂ ಅಲ್ಲಿ ಹಿಯರ್ ದ ಮೋರ್ ಕ್ರೋಮಿಯಂ ಇಟ್ ಈಸ್ ಶೋಯಿಂಗ್ ದ +6 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ಯಾಕಂದ್ರೆ +6 ಸ್ಟೇಟ್, ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ +6 ಕ್ರೋಮಿಯಂ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನು? 4s1 3d5 ಅಲ್ಲ. ಈಗ ನಾನು 6 ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಿದರೆ ಇಟ್ಸ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ವಿಲ್ ಬಿ ದ +6. ನೋ ಮ್ಯಾಂಗನೀಸ್ಗೆ +7. ಬಟ್ ವೆನ್ ಇಟ್ ಕಮ್ಸ್ ಟು ದ ಫೆರ್ರಸ್, ಫೆರ್ರಸ್ ಈಸ್ ಸ್ಟೇಬಲ್ ಇನ್ ದ +3 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ಯಾಕಂದ್ರೆ ಹಿಯರ್ ಫೆರ್ರಸ್ ಅಲ್ಲಿ ಐರನ್ ಅಲ್ಲಿ ನೋಡಿ, ಐರನ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನು? 4s2 3d6 ಅಲ್ಲ, 4s2 3d6. ಈಗ ನಾನು ಒಂದು 2 ಎಲೆಕ್ಟ್ರಾನ್ ಮತ್ತೆ ಇಲ್ಲಿಂದ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಇಟ್ ವಿಲ್ ರೀಚ್ ಟು ದ 3d5 ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅಲ್ಲ, 3d5 ಸ್ಟೇಬಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್. ನೌ ಇಟ್ ಈಸ್ ಸ್ಟೇಬಲ್ ಇನ್ ದ +3 oxidation state. Now here the cobalt also, now these are the variable oxidation states shown by the 3d group elements. But in the transition state alli valency shell ಮತ್ತೆ inner transition shell ಅಲ್ಲಿ d orbitals ಎರಡೂನು ಬಾಂಡ್ ಅಲ್ಲಿ ಪಾರ್ಟಿಸಿಪೇಟ್ ಆಗುತ್ತೆ. Okay, it will participate ಮಾಡುತ್ತೆ. Fine. Now these are the oxidation state of the next oxides of the 3d elements. Now oxides of the 3d elements ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ, ಇಲ್ಲಿ ನೋಡಿ ಆಕ್ಸೈಡ್ಸ್ ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ, ಹಿಯರ್ electron donors are acids, electron acceptors are base ಅಲ್ಲ. electron donors are the acids, electron donors are the bases, electron acceptors are the acids alla. Now when we move from the left to right, ಏನಾಗುತ್ತೆ? when we move from the left to right, acidic nature increases. Now when we move from the top to bottom, acidic nature decreases alla, now ಇಲ್ಲಿಂದ ನೋಡಿ, ಈಗ ಜಾಸ್ತಿ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇದೆ ಅಂದ್ರೆ ಆನ್ ದ ಆಟಮ್ ಎಲಿಮೆಂಟ್ ಆರ್ ಇನ್ ದ ಕಾಂಪೌಂಡ್ ಸೆಂಟ್ರಲ್ ಆಟಮ್ ಇಫ್ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್, ದಟ್ ಈಸ್ ಸ್ಟ್ರಾಂಗ್ ಆಸಿಡ್. ಈಗ ಇಫ್ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಕಡಿಮೆ ಲೆಸ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್, ಅದು ಬೇಸ್. ಇದರಲ್ಲಿ ಇನ್ ಬಿಟ್ವೀನ್ ಇಫ್ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಆಂಫೋಟರಿಕ್. ಇಲ್ಲಿಂದ ನೋಡಿ, this titanium dioxide is a amphoteric. ಯಾಕಂದ್ರೆ titanium dioxide oxidation state ಎಷ್ಟು? ನಾವು ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡಬಹುದು? ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ titanium dioxide ಅಲ್ಲ, titanium dioxide. Now this is a central atom. Now this is a x plus 2 into oxidation number of this is a -2. Then x is equal to +4 ಅಲ್ಲ. Now titanium oxidation state is +4. But it is behaving as a amphoteric. This is behaving as a amphoteric. Now ಇಲ್ಲಿಂದ ನೋಡಿ, now here acid. Now vanadium pentoxide it is acting as a acid. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ vanadium ಎಷ್ಟು? 2x ಅಲ್ಲ, ಪ್ಲಸ್ ಆಕ್ಸಿಜನ್ ಎಷ್ಟು? 5 - 2 x is equal to +5 ಅಲ್ಲ. Here it is having the higher oxidation state. That's the reason it is acting as a acid. Now here these are the examples. Now here the vanadium oxide oxidation state will be the +2. That's the reason the ಎರಡು basic oxide. Now this is a acid. Now this is a amphoteric. ಇದರಲ್ಲಿ ಯಾಕಂದ್ರೆ this oxidation state of the this one vanadium, it is a +4. It is in between the +2 as well as the +5. ಅದಕ್ಕೋಸ್ಕರನೇ vanadium it is acting as a amphoteric. Here also these are the examples of the amphoteric. Now you have to remember, these are the basic oxides. Now this is also amphoteric oxide. Now these are the examples. Now okay, next magnetic property ಅಂದ್ರೆ, here we are having the paramagnetic. and diamagnetic alla, paramagnetic and the diamagnetic. Paramagnetic andre here n should be not equal to 0. Here diamagnetic andre n should be equal to 0. Here n andre number of unpaired electrons, number of unpaired electrons. Now how to find out the magnetic property? Now that is magnetic property is equal to under root n into n plus 2 Bohr magnetons. ಇಲ್ಲಿ ನೋಡಿ scandium plus 3 ಅಲ್ಲಿ here configuration will be d0, the number of unpaired electrons will be 0 and the magnetic moment will be 0. Now scandium plus 3 andre now electronic configuration is to 4s1 4s2 3d1 alla. Now by removing 3 electron it will get the scandium plus 3 andre here have removed this 3 electron. Now we are having the empty orbitals. N is equal to 0. Iga n is equal to 0 andre here total magnetic momentum unpaired electrons will be 0, the magnetic momentum calculated will be 0, observed will also be 0. ಇಲ್ಲಿ ನೋಡಿ mn plus 2 ನನಗೆ ಈಗ mn plus 2 ತಗೊಂಡಿದ್ದೇನೆ ಅಂದ್ರೆ mn plus 2 ಅಂದ್ರೆ mn plus 2 electronic configuration ಎಷ್ಟು 4s2 3d 5 ಅಲ್ಲ 3d 5. now by removing the electrons, now d ಇಂದ electron remove ಮಾಡಬೇಡ, ಯಾಕಂದ್ರೆ this is the inner electron will be removed from the valency shell only. We will remove the electron from the valency shell only. Okay, now if you remove the electrons from the s orbital, now the remaining unpaired electrons will be 5 alla, here the n value is 5. Here the n is unpaired electron alla, 5 into 7 ಎಷ್ಟಾಗುತ್ತೆ 35. root 35 value is to calculated we are getting the 5.92, observed value is the 5.96. Now this is the formula to find out the magnetic property of the any elements they have given, if they have given. Okay, next formation of the color diagram. Now here d block elements are the transition elements. Color they will give the color. How ಹೆಂಗ್ ಕೊಡಿತಾರೆ ಅಂದ್ರೆ due to dd transition, due to the dd transition these elements will show the color due to the dd transition. Here d10 d0 ಮತ್ತೆ d10 configuration elements, d10 ಮತ್ತೆ d10 electronic configuration elements are these are the colorless. ಯಾಕಂದ್ರೆ ಈಗ ನಾನು ಒಂದು octahedral complex ತಗೋತಾ ಇದ್ದೀನಿ. octahedral complex ಅಲ್ಲಿ ಇಲ್ಲಿಂದ this is 2 G, this is the EG. ಇಲ್ಲಿಂದ electrons, here if the electrons, now here this is exciting from the 2G to the EG. Now this is the DD transition. ಇದನ್ನ ಏನಂತಾರೆ DD transition. Now, electrons are exciting from the 2G to the EG. ಅದಕ್ಕೋಸ್ಕರನೇ these elements are showing the colored. Okay. Now ಈಗ D10 means all the electrons are filled. ಈಗ all the elements are filled. Now ಈಗ if this all the elements are filled, now EG will accept the electron. ಯಾಕಂದ್ರೆ EG also filled ಅಲ್ಲ, ಅದಕ್ಕೋಸ್ಕರನೇ here the D0 ಮತ್ತೆ D10 configuration elements are colorless. Rest all are the colored. Now these elements are showing colored because of the DD transition alla, DD transition. Now there are some elements which can be shown due to the charge transfer. ಯಾವ್ದದು KMnO4 ಮತ್ತೆ potassium dichromate. Now these are the some examples without DD transition. These are showing the color due to charge transfer. Due to the charge transfer these are showing the color here. Okay, remaining all are the showing due to the DD transition. Okay, next. Some properties. Now here D block elements alli, transition elements alli, some elements it's showing some properties. Here the first one, here first is a potassium dichromate. Potassium dichromate, how we can find out, how we can synthesize the potassium dichromate? Yakandre how andre illi nodi, potassium dichromate is synthesized from the chromite ore. First potassium dichromate is synthesized from the chromite ore. E chromite ore alli, chromite ore, this FeCr2O4 is a chromite ore. This chromite ore is fused with the sodium hydroxide in the presence of oxygen. In the presence of oxygen. ಈಗ ಏನು ಬರುತ್ತೆ, Na2CrO4, Na2CrO4, Na2CrO4 ಇಲ್ಲಿ ನೋಡಿ, ಫ್ಯೂಸ್ಡ್ ಮಾಸ್ Na2CrO4 and Fe2O3 plus 8O2 ಬರುತ್ತೆ, 8H2O ಬರುತ್ತೆ. See, the fused mass is treated with the hot water. This ಎಲ್ಲ fused mass will be treated with the hot water. Now Na2CrO4 goes into the solution and Fe2O3 is not soluble by the H2O. This Fe2O3 ferrous oxide will not be soluble in the water. That's the reason ferrous oxide is removed by the filtration. Ferrous oxide will be removed by the filtration. Okay, next. Now here some properties of the elements. Potassium dichromate, how we can find, how we can synthesize the potassium dichromate anta nanu helta idini. Illi nodi, first it is formed from the chromite ore. A chromite ore, this is fused with the, we are reacting with the sodium hydroxide in the presence of oxygen. Agu barutte, ಆಮೇಲೆ we have separate ಮಾಡಿದ್ವಿ, ಈ ಎರಡೂನು separate ಮಾಡಿದ್ವಿ. ಆಮೇಲೆ ಏನು ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ, now here this Na2CrO4, it is a yellow in color. This yellow color, it is treated or reacted with the dilute H2SO4. ನಮಗೆ ಏನು ಕೊಡುತ್ತೆ, sodium dichromate. Sodium dichromate ಬರುತ್ತೆ. This sodium dichromate is a orange in color. Sodium dichromate. Now after that sodium dichromate, this sodium dichromate is reacting with the KCl. By reacting with the sodium dichromate which is in the orange color, that orange color sodium dichromate ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, now it is reacting with the KCl. After reacting with the KCl ನನಗೆ ಏನು ಬರುತ್ತೆ, potassium dichromate. Potassium dichromate and the NaCl. Potassium dichromate and the NaCl. ಇಲ್ಲಿ ನೋಡಿ, because of the solubility difference, ಈ ಎರಡರಲ್ಲಿ solubility difference, due to the presence of the solubility difference of potassium dichromate and the NaCl, they can be separated by the fractional crystallization. Due to the fractional crystallization, we are separating the NaCl. NaCl is a salt alla. Now salt ಮತ್ತೆ potassium dichromate we are separating by the fractional distillation. By this we are getting the potassium dichromate. Potassium dichromate. Okay, next potassium permanganate. Now potassium permanganate ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ, ಇಲ್ಲಿ ನೋಡಿ, how to synthesize the potassium permanganate ಅಂದ್ರೆ, here the potassium permanganate is synthesized by the pyrolusite. Now this potassium permanganate is synthesized by the pyrolusite. Pyrolusite is the chief ingredients of the manganese dioxide. Manganese dioxide. ಈಗ ಈ manganese dioxide is fused with the ಏನಿದು, potassium hydroxide in the presence of oxygen. ನಮಗೆ ಏನು ಬರುತ್ತೆ, now what we are getting, ಏನು ಬರುತ್ತೆ, potassium manganate ಬರುತ್ತೆ. ಈಗ this manganese dioxide, when we are treated with the potassium hydroxide with the O2, what we are getting, potassium manganate we are getting. Now from this potassium manganate, how to find out the potassium permanganate? How to find out the potassium permanganate? How can we synthesize the potassium permanganate andre, ಒಂದು ಮೆಥಡ್, ಫಸ್ಟ್ ಇಸ್ ಎಲೆಕ್ಟ್ರಾಲಿಸಿಸ್. ಡ್ಯೂ ಟು ದಿಸ್ ಎಲೆಕ್ಟ್ರಾಲಿಸಿಸ್ ಮೆಥಡ್ ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್ ಔಟ್ ದ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟ್. ಎಲೆಕ್ಟ್ರಾಲಿಸಿಸ್ ಅಂದ್ರೆ ಏನು? ಎಲೆಕ್ಟ್ರಾಲಿಸಿಸ್ ಅಂದ್ರೆ ಇಲ್ಲಿಂದನೇ ಕ್ಯಾಥೋಡ್ ಮತ್ತೆ ಇಲ್ಲಿಂದನೇ ಆನೋಡ್ ಇರುತ್ತಲ್ಲ, ಆನೋಡ್. ನೌ ಹಿಯರ್ ನಾನೇನು ತಗೋತಿದ್ದೀನಿ, ಹಿಯರ್ ವಿ ಆರ್ ಹ್ಯಾವಿಂಗ್ ದ ಪೊಟ್ಯಾಷಿಯಂ ಮ್ಯಾಂಗನೇಟ್ ಅಲ್ಲ, ಈ ಪೊಟ್ಯಾಷಿಯಂ ಮ್ಯಾಂಗನೇಟ್ in the electrolysis, it will be converted into ions alla. Here there is a aqueous. ಈ H2O ಅಲ್ಲಿ ನಾವು ನಾನೇನು ಡ್ರಾಪ್ ಮಾಡಿದ್ದೀನಿ, ಪೊಟ್ಯಾಷಿಯಂ ಮ್ಯಾಂಗನೇಟ್ ಡ್ರಾಪ್ ಮಾಡಿದರೆ now it will be converted into ions alla, it will be converted into K plus and the MnO4 minus 2. Now the water is partially hydrolysis ಅಂದ್ರೆ H plus and the OH minus ಕೊಡಿಸಲ್ಲ in electrolysis ಅಲ್ಲಿ only. This is in the electrolysis only, it is happening in the electrolysis only. Now water is partially hydrolyzed. Now after the partially hydrolyzed, now cathode and the anode, H2O gas will be deposited at the cathode. In that electrolysis ali H2O gas will be deposited at the cathode. Now here MnO4 minus will be deposited at the anode. Here potassium manganate which is in the green color, it is converting into the potassium permanganate. Now at the anode this green color is converting into the purple color which is a potassium permanganate. Illi nodi, as the electrolysis continues, green color converted into purple color. Next. Now here the next method to prepare the potassium permanganate andre, here the potassium manganate ತಗೊಂಡಿದ್ದು ಅಂದ್ರೆ ಈಗ if you are reacting with the chlorine gas, we are getting the potassium permanganate. Now this potassium permanganate is a next. Now this potassium permanganate is a strong oxidizing agent alla, Now this potassium permanganate, it will react with the acidic medium, basic medium as well as a neutral medium. This potassium permanganate ಬೇಸಿಕ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ, ಆಸಿಡಿಕ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ, ಮತ್ತೆ ನ್ಯೂಟ್ರಲ್ ಮೀಡಿಯಂ ಅಲ್ಲಿನೂ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ನೋಡಿ, potassium permanganate when you have heated, it is giving the potassium manganate plus manganese oxide plus O2 gas. ಅಂದ್ರೆ here oxygen gas can be synthesized by the thermal decomposition of potassium permanganate. ಈಗ thermal decomposition potassium permanganate ಗೆ thermal decomposition ಮಾಡಿದೆವು ಅಂದ್ರೆ ನಮಗೆ ಏನು ಬರುತ್ತೆ, oxygen ಬರುತ್ತಲ್ಲ, the oxygen it will be getting. Now these are the some reactions of the potassium permanganate when you are reacting with the strong acid H2SO4. what it is giving MnSO4 plus K2SO4 plus 3H2O, and it will give the nascent oxygen. This nascent oxygen is responsible for the oxidation. Now ಈ nascent oxygen ಏನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಆಕ್ಸಿಡೇಷನ್ ಮಾಡುತ್ತೆ. ಈ KMnO4 ಅಲ್ಲಿ now KMnO4 is acting as a oxidizing agent ಅಲ್ಲ, strong oxidizing agent ಅಲ್ಲ. ಯಾಕಂದ್ರೆ this nascent oxygen will oxidize the other elements, okay, other compounds. ಇಲ್ಲಿ ನೋಡಿ, KMnO4 is reduced to the Mn plus 2 salts. ಇದು Mn plus 2 salts. These Mn plus 2 salts are colorless. So purple color of the KMnO4 changes to the colorless. ಈಗ KMnO4 is a purple color ಅಲ್ಲ, ಇಲ್ಲಿ ನೋಡಿದೀವಲ್ಲ ಎಲೆಕ್ಟ್ರಾಲಿಸಿಸ್ ಮೆಥಡ್ ಅಲ್ಲಿ ನೋಡಿದೀವಲ್ಲ, ಗ್ರೀನ್ ಕಲರ್ ಹ್ಯಾಸ್ ಬಿನ್ ಕನ್ವರ್ಟಿಂಗ್ ಇಂಟು ಪರ್ಪಲ್ ಕಲರ್. KMnO4 is a purple color. ಈಗ ಪರ್ಪಲ್ ಕಲರ್, ನಾವು KMnO4 when it is reacting in the acidic medium ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಪರ್ಪಲ್ ಕಲರ್ ಆಫ್ ದ KMnO4 disappeared to the colorless. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿಂದ Mn plus 2 salts are the colorless. So the purple color changes to the colorless. ಇಲ್ಲಿಂದ this nascent oxygen is responsible for the oxidation of the KMnO4. Next ಏನಂದ್ರೆ the inner transition elements ಏನಂದ್ರೆ F block elements ನ ಏನಂತಾರೆ ಅಂದ್ರೆ ಇನ್ನರ್ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತಾರೆ. ಇಲ್ಲಿ ನೋಡಿ, F block elements consist of the two series, ಒಂದು lanthanides ಒಂದು actinides. ಈಗ lanthanides it will start from the lanthanum and it will end from the lutetium. Now actinides it will start from the actinides and it will end from the lawrencium. Okay, now lanthanides here inner transition elements. Now ಇಲ್ಲಿಂದ periodic table ಅಲ್ಲಿ D block elements ಅಲ್ಲ, D block elements. D block elements ali, this is the third period. Third period ali, this is fourth. Now from F block elements will start from the 6th period, 6th and the 7th period. Here the lanthanum and here it is the actinides. Lanthanides and the actinides, instead of placing in the long form of periodic table, they have placed it in the downside of the periodic table. Now it will start from the 6th period, 6th and the 7th period. Now it is having only the one group. It is having only the one group. Lanthanides inner transition elements onde group ide, adu yavud group ande third group. Lanthanides and the actinides F block elements having only the one group, that is the third group, but it is having the two periods, 6th period as well as the 7th period. Now lanthanides will start from the lanthanum and end at the lutetium. Now actinides will start from the actinide and it will end at the lawrencium. Now general electronic configuration of the inner transition elements ಏನಂದ್ರೆ n-2 F1 to 14. Now n-1 D 0 to 2. Now NS2. This is the general electronic configuration of the F block element. This is the general electronic configuration of the F block elements. Now lanthanides and the actinides. Lanthanides will start from the 6th period. Now this will start from the 7th period. Now this will start from the 6th period. Now we'll see what are the elements that present in the lanthanides and what are the elements that present in the actinides. Now lanthanides is starting from the lanthanum and ending at the lutetium. Now illinda nodi, these are the elements that are present in the lanthanides and it is having the different variable electronic configuration. This is a general electronic configuration if you remove the two electrons. Now illinda no same, if you take the cerium, now 4f1 cerium, 4f1 5d1 6s2. If you take the cerium electronic configuration, now there we are having Ln plus 2. If you want to make the cerium plus 2 and the cerium plus 3, now here the first electron you should remove from the valency shell. Now you should not remove from the inner shell. Okay, now if you want to remove the electron, you should remove from the valency shell only. Now these are the elements that present in the lanthanides. Now next actinides. Now these are the elements that are present in the actinides. It is started from the actinium and it is ending at the lawrencium. Most of the actinides are the radioactive elements. These are the radioactive elements. Now these are the elements that present in the actinides. This you have to remember. Next, difference between the lanthanides and the actinides. ಏನಂದ್ರೆ ನೋಡಿ, lanthanides in the addition of +3 oxidation state, they can exhibit the +2 and the +4 oxidation state. Now oxidation state ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡ್ಬೋದು? By the removing of the valency electron. From that ಎಷ್ಟು electron remove ಮಾಡ್ತೀವೋ ಅಷ್ಟು it will be the oxidation state on that element. ಈಗ ನೀವು 2 electron remove ಮಾಡಿದೀವಿ ಅಂದ್ರೆ +2 is the oxidation state. ಈಗ 3 if you remove ಮಾಡಿದೀವಿ ಅಂದ್ರೆ +3 will be the oxidation state. ಇಲ್ಲಿ but actinides also it is having the +3 oxidation state and it will show the +4 as well as the +5, +6 and the +7 oxidation state. Now most of these ions are colorless. ಈಗ ನಾನು ಹೇಳಿದನಲ್ಲ, colorless means it should have the completely filled or incompletely, totally 0. D0 and the D10 are the colorless that we have seen in the transition elements. Illindanu same. F0 and F14 are the colorless, but some exceptions are there. Illindanu some exceptions irutte. Even though it is having the half filled and incompletely filled, even though they are also colorless. This most of them are the colored. Actinides ali most of them are the colors. Now they do not form the complex easily. These lanthanides elements in the complex, they are not easily form the complex. No, they are much greater tendency to form the complex. Actinides, they are much tendency to form the complex. Okay, next they do not form the oxocations. Lanthanides oxocations form madalla, they will form the oxocations. ಇಲ್ಲಿ ನೋಡಿ oxocations. These are the cations. Now these compounds are less basic. Lanthanides are the less basic. These compounds are the more basic. Basic andre acid, these are the less basic, these are the more active. Now helidinalla, most of the actinides are the they all are the radioactive elements. Actinides are the radioactive elements. Here except promethium, they are non radioactive. Promethium, illinda lanthanides alli promethium andu element irutte, that is the, what is that? That is the radioactive elements. Adu bittu ellanu non radioactive elements. Adu bittu all are the non. Now their magnetic property can be easily explained. Now lanthanides ge magnetic property easily explain ಮಾಡಾಗುತ್ತೆ. But when it comes to the actinides, magnetic property cannot be easily explained. Okay. Now next. By this we have finished our the summary. Now what are the important content in the D and F block alli nodidivalla. Now these are the important content. This will be helpful for your upcoming preparation for the KCET, JEE mains as well as the NEET. Okay, bye.